In this video, we'll look at solving some exponential equations that arise from compound interest. First, we'll look at finding the time in a word problem on compound interest. So remember that on your formula sheet, you have the compound interest formulas. When you have compounded n times per year, your formula is A equals P times the quantity 1 plus R over N quantity to the NT power. You'll solve the exponential equation using logarithms if needed. In our example, we're told that Cole deposited $4,000 into an account with a 9.4 annual interest rate, compounded quarterly. So let's pick out the pieces that we know. We know that our initial amount was 4,000. So that will be our capital P. And 9.4 annual interest rate, that will give us R. And we want R written as a decimal. So 0.094. And compounded quarterly means that it's 4 times per year. So N equals 4. Assuming that no withdrawals are made, how long will it take for the investment to grow to $7,148? So growing to that amount, that's going to be A. Do not round any intermediate computations. Round your final answer to the nearest hundredth. So I'm going to use this formula up here. My A value is 7,148. P is 4,000. Then I have parentheses 1 plus R over N. So 1 plus 0.094 over 4. To the NT, and N is 4, so to the 4T. All right, so I want to try to simplify if possible. And what I'll do first is I'll go ahead and compute 1 plus 0.094 over 4. So that gives me 1.0235, and that's exact. So I can go ahead and use that. It says do not round any intermediate answers, but I'm not rounding if I go ahead and use the whole number here. So 1.0235. All right, so I'll rewrite this and I'll go ahead and do 7,148 equals 4,000 parentheses 1.0235 to the 4T. All right, so now it looks very similar to some of those exponential equations that we solved in previous lessons. So I'm going to go ahead and divide by 4,000 on both sides. Get rid of the coefficient in front of your exponential term. So those 4,000s cancel. And I don't want to round the 7,148 over 4,000, but I could see if there's a nice simpler fraction I could write. So 7,148 divided by 4,000. So that actually comes out as a nice number, 1.787, or you can write it in its fraction form. So 1.787, it came out exact, so I'm not actually rounding there. equals 1.0235 to the 4t. And now here's the point where I want to take the log or natural log of both sides. So it doesn't matter if you use log or ln. I'll go ahead and use log. So I'll have log of 1.787 equals log of 1.0235 to the 4t power. And I'll use my exponent property, my property of logs, my power property, to rewrite this as log of 1.787 equals 4t log of 1.0235. Now at this point, I just want to get t by itself, so I'll divide both sides by 4 log of 1.0235. All right, so t is by itself, and I can go ahead and put that into my calculator now. So I have log, let me grab my log function. So log of 1.787, close the parentheses, divided by 4 log of 1.0235. Notice I haven't rounded any of the intermediate steps. I've written the entire decimal. So I get 6.248225031. So they say round to the nearest hundredth, so that would be 6.25. So I get 6.25, and our time interval is in years. So I'll get 6.25 years. In order for the investment to grow to 7,148. So use the formula for compound interest and then solve using the methods that we use to solve exponential equations with a single exponential term. Let's look at one more example. In this one, we want to find the initial amount in a word problem on continuous compound interest. So this is also on your formula sheet. Your continuous compound interest formula is A equals PE to the RT. And what you'll want to do is go ahead and plug in the numbers you know and then solve for the unknown. Stephanie wants to buy a bond that will mature to $6,500 in 7 years. So mature to that amount, that means we want that to be our final amount. So that's actually our A value. And in 7 years, that's going to be our T value. How much should she pay for the bond now if it earns interest at a rate of 4% per year? So that gives us R equals 0.04, compounded continuously. So that's what tells us to use the A equals PE to the RT. Do not round any intermediate computations, but round your final answer to the nearest cent. All right, so I'm going to go ahead and put in the numbers that I know. A is 6,500. Okay, so I have 6,500 equals PE to the 0.04 times 7. So 0.04 times 7. I want to go ahead and figure out what that number is. So let me plug that into my calculator here. So I have 0.04 times 7, 0.28. So this will be 6,500 equals PE to the 0.28. Now remember, E is just an irrational number, kind of like pi. So I can divide by E. So I can divide by the E to the 0.28. Divide the other side by E to the 0.28. And so I'm going to get P equals 6,500 divided by E to the 0.28. And we just put that into the calculator. $6,500 divided by, to get E, you can go to function here and select E to the X. Go back to your main menu and put in 0.28 as the exponent. And we've got our amount. They say round to the nearest cent, so that would be 2 decimal places, $4,912.59. So that would have to be her initial investment if she wanted to earn up to, get the total up to $6,500 in 7 years. So that would be the initial investment. So we're using our compound interest formulas, and then we're using our knowledge of solving exponential equations in order to find the unknown.